In the previous nugget, we took a look at the concepts and ideas regarding fault tolerance for a VM, and in this nugget, we're going to take a look at the implementation of the feature. Beginning in the hands-on lab vSphere web client, let's go ahead and click on VM5. And with VM5 selected, let's click on the summary tab. And let me bring this full screen so we can see a little bit better. And for the summary of VM5, I'm going to expand this window just a little bit to the right so we can see everything. We can also reposition these windows as well. So I'm going to click and drag the VM failure response up just a little bit. And also, if we wanted to bring one of these up full screen, we could go ahead and click on this icon right here to maximize that window. And that would put it down here at the bottom so we could see it. And then we could go ahead and click on the icon up here again in the right corner to restore back down. So currently this VM, VM5, the one we're going to enable fault tolerance on, currently it's associated with ESXi3. And it's got some storage on a data store cluster. So that's iSCSI1 or iSCSI2. So before we enable the fault tolerance, here's what I'd like to do. I'd like to do a migration and move VM5 over so its host is ESXi2 and that its data store is specifically iSCSI-1. And that way we can use it as a nice easy starting point so we can know where that machine is originally. So because that machine's powered off, it'll be called a migration as opposed to a vMotion. So we'll right click on VM-5, and from the action menu for VM5, we'll click on migrate, and then we're going to click on this third radio button, change both the compute resource and storage, and we'll start off by selecting the compute resource, and then we'll select the storage based on the wizard that'll be presented to us. So we'll click on next. We'll open up the USA folder, open up the Las Vegas data center, and we'll expand cluster 2, and we specifically want the compute resource to be ESXi2. So we're going to select it again so we know where we're starting from for the fault tolerance, and we'll click on next. Next, we're going to go ahead and click on the checkbox to disable storage DRS because we want to specifically identify iSCSI1, and we're also going to make sure that it goes over as thin provisioned. And with iSCSI1 selected, we'll click on next. And we'll leave it on the distributed switch port group named DSVM port group and click next. And then we'll click on finish. So if we click on recent tasks, we can just keep an eye on that and we'll wait till it finishes. And then we'll continue with the fault tolerance configuration. And hooray, it's done. So we'll go ahead and we'll minimize the recent tasks. And just to confirm, right over here in the related objects, we're currently associated with ESXi-2. And because we just migrated the storage to iSCSI-1, we know our starting point. Now, if we wanted to, we could just right-click on VM-5 and then hover over fault tolerance from the actions menu for VM5, and then we can click on the submenu item of turn on fault tolerance. Now, in the previous nugget, we talked about lots of things that have to be in place for this to work. So if we attempted to enable fault tolerance and some of those elements weren't in place, we get some messages that indicate that. So we'll click on turn on fault tolerance and then read the nastygrams. We've got a message saying, hey, you've got a CD-ROM that's not going to be supported with fault tolerance. So if that CD-ROM is backed by some local resource that's only available, for example, on the current ESXi host, that would be a problem. Or if it's got an ISO image in it that's associated with a local data store only, that's a problem. Because the secondary VM that's running on a different host wouldn't have access to that. So we'll fix the CD-ROM issue. And the other warning is that we don't have the FT logging enabled on ESXi2. And all the hosts in the cluster that are going to be supporting the fault tolerance need to have FT logging so that the primary or secondary could run on any of the hosts in the cluster. So we'll enable FT logging as well on ESXi2 and 3. So we'll click on OK. And let's first deal with VM5 and the CD/DVD drive. So we can right click on VM5. Or if VM5 is currently selected, we can click on Configure, and then click under Settings, VM Hardware, and then click on Edit. Or, because we were right there, we could right-click on VM5, and then from the menu, simply click on Edit Settings, and it's going to take us to the same place, the Edit Settings window. So from here, if we want to get rid of the CD-ROM, all we need to do is just go to the far right here. There's a little X. You just click on the X to remove that hardware, that virtual hardware. This little coloring here indicates it's about to be deleted, and we'll click on OK. And it's gone. Our second challenge was that the ESXi host didn't have VM kernel adapters enabled for FT logging. So to fix that, let's go ahead and click on ESXi2 here on the left, and then we'll click on the Configure tab, and then we're going to go under Networking and select VM kernel adapters. So we have 4 VM kernel adapters currently in place, VMK0 through 3. The first one we're using for management, VMK1 and 3 we're using as part of our multipath solution for iSCSI access. And VMK2 we're currently using for vMotion. And that's one of the benefits of having meaningful network labels, is so that we can remember how those are being applied and what they're being used for. So currently VMK2, which is associated with the VM kernel port group called VMK-vMotion and associated with the standard switch of switch 3, at the moment it's only enabled for vMotion. So if we wanted to add the additional functionality of FT logging, all we do is make sure that VMK2 is highlighted, click on the little pencil icon for edit, and then here in the port properties regarding VMK2, we simply click on the box for fault tolerance logging. And that will allow that feature associated with this VM kernel adapter. So we'll go ahead and click OK, and then we'll do the same thing over for ESXi3. So we'll click on ESXi3 on the left. Under networking, we're going to go again to VM kernel adapters. We'll click on VMK2, click on edit settings, and enable the fault tolerance logging on that adapter as well, and click OK. And because those are the only two hosts in our cluster, we're now set, because every host in this cluster has a reachable IP address through VMK2 that's enabled for FT logging. And if you're working in a new environment and you're not sure how everything is currently set up, we also ought to just check real quick to make sure high availability is enabled, because that's a requirement to have fault tolerance on a VM. So we'll click on cluster 2 on the left hand side, and then if we click on the monitor tab for cluster 2, and then we click on the button here for vSphere high availability, currently we have a master of ESXi3, and then we have another host connected to that master, and we currently don't have any failed hosts or other negative issues regarding high availability. We can also click on the heartbeat section here and identify the data stores that are currently being used for data store heartbeats. So if we were to go to either one of those, in fact, let's go ahead and click on the storage tab just for a moment, and then we'll click on iSCSI2. And with iSCSI2, if we click on the Files tab, at the moment we don't have any VMs that are currently using this data store. But there is this folder called .vsphere-ha. If we open that up by clicking on it, there's also a subfolder that starts with FDM. So if we go into that, check this out. Here we have heartbeat files for host 35 and host 39 respectively, which I would guess would be ESXi2 and ESXi3. So the data store heartbeats are used as a mechanism in HA to identify, okay, did the other host crash, or is it just unreachable over the management network? So let's go back to host and clusters. And we're verifying here that HA is configured on the cluster, which it is. There's no configuration issues. And this tab here for data stores under all paths down or permanent device loss is not reflecting any problems, and that's also a very good thing. However, as I recall, when we put the high availability together, we did not enable the enhanced vMotion compatibility. So since we're right here at the cluster, let's go ahead and click on Configure, the Configure tab. And then under Configuration, we'll go down to VMware EVC, which is the enhanced vMotion compatibility. And if we enable this on the cluster, it allows us to use fault tolerance for the cluster along with vSphere's DRS. So with the VMware EVC selected, we'll go ahead in the upper right hand corner and click Edit. So currently it's disabled. We are currently running on Intel processors on our hosts, so we'll click on the Enable EVC for Intel hosts, and then we're going to specify the baseline feature set. Now for fault tolerance, I know we need at least Sandy Bridge or better, so I'm going to go ahead and choose Sandy Bridge. We don't have any VMs that are currently running, and if we did and there's a VM that was currently using some feature that wasn't supported by this generation of Intel processor, it would not let us continue. But since they're all powered down and we're not using any features that are very fancy on the VMs, we'll select Intel Sandy Bridge generation and click OK. So now enhanced vMotion compatibility is enabled for the cluster. So now that the cluster is configured with high availability and EVC, and DRS also is enabled, we can click on vSphere DRS and verify that it's enabled here as well. We're now ready to go ahead and enable fault tolerance on a VM. So let's click on the VMs view here, the tab for the cluster. And there's all of our current VMs. Some of these are part of a VApp. One has a CPU limit, one has a reservation, and VMs 1 through 5 are pretty much plain Jane. So our goal is to enable fault tolerance on VM5. So we can just right click on VM5, and from the Actions menu, we can go up to Fault Tolerance, and then from the submenu select Turn on Fault Tolerance. vCenter already knows where VM5 lives. VM5 is currently being supported, or if it was powered on, it would be supported by ESXi2, and it's using the data store of iSCSI1. So what this question is about here is select the data stores to place these secondary VM disks and configuration files. So the actual disks can be on a local data store of the other ESXi host in the cluster, but the actual configuration file for the VM has to be on shared storage. And most of the time we're going to use shared storage for both. Also, notice here that it's not showing us the data store cluster itself as a target. It's not showing up in the list. Now we can choose iSCSI1 or iSCSI2, which are both members of a data store cluster. However, we need to choose them specifically. Also, if we wanted to, we can click on this Advanced button right here. If we click on Advanced, we can specify exactly where we want the files. So regarding the configuration files, if we click on Browse, it's showing us a list of the network-based data stores. So we could choose, for example, iSCSI2, click OK, and the configuration file for the secondary VM would be placed there. For the hard disk file, which could be on local storage or network-based storage, we can click on Browse, and we have the 3 network-based storage choices again, but we also have ESXi3 data store. Now the reason it's showing us ESXi3 is because that's the other host in the cluster. So the primary is going to be running on ESXi2, and because the secondary is going to be running on ESXi3, that's why we can choose ESXi3's local data store for the disk files. So we could choose ESXi3 as the data store, click OK, and then we have a tiebreaker file which is also used by fault tolerance, and it has to be network-based storage. So I'm going to click Cancel, and I'm going to go back to the basic view, and I'm going to tell it to go ahead and put all those files on iSCSI2. And we could choose iSCSI1, but I'm going to choose iSCSI2 just because it's a different data store. And then let's click on Next. Next, it's asking, hey, where do you want to run the secondary VM? And once again, because we only have one other host in the cluster, that's our only choice here. So we'll select ESXi3 and click on Next. It's giving us a summary, and we'll click on Finish. So check this out. With Cluster 2 selected and on the VMs tab, and looking at the virtual machines, it's now showing VM5 with a slightly darker icon for the VM, and in parentheses, the word primary, and it's associated with ESXi2. And then we also have the VM5 secondary, which is associated with ESXi-3. Also, if we were to click on VM-5 over here on the left in the navigator pane, and then click on the summary tab for VM5, and then if we scroll down, we're going to have a pane for fault tolerance, and it is right here. So let's drag that up a little bit higher so we can see it without having to scroll down. So I just dragged and dropped it right here. And at the moment, our fault tolerance status is not protected. That's partly because the VM is not running. And when we power on VM5, it's going to trigger a high availability event. And that's because the secondary machine is not running yet. So that secondary machine will be brought up on ESXi3. And then once it's fully initialized and running, from a fault tolerance perspective, it should show VM5 as protected. And then anything we do on VM5 will be replicated to the host running the secondary over the IP addresses and over the networks associated with the VM kernel adapters that have been enabled for fault tolerance logging. So let's go ahead and power on VM5. We'll right click on VM5, and from the Actions menu, we'll hover over Power, and from the submenu, we'll click Power On. So as this powers on, we have an alarm, virtual machine fault tolerance state changed, and if we click over here in the alarm section to bring that up, we can go ahead and click on that alarm, which gives us more details about that. And it states this is a default alarm monitoring changes in the fault tolerance state of a virtual machine, and because it just powered on, that is certainly a state change. So we can go ahead and either from this drop down, we can go ahead and acknowledge it, or we can reset it to green, and it's happy. Also, if we go down to recent tasks, check this out. It started the fault tolerance secondary VM. So it started off at this timestamp, which is 40 minutes and 7 seconds after the hour, and it completed close to a full minute later. So just be aware that when you first boot up that machine, click on recent tasks and give it a minute just to go ahead and completely get that secondary machine up and running. Alright, so let me go ahead and minimize recent tasks. Also here with VM5 selected, we have the message that it's currently protected, and check this out. 95,831 kilobits per second. So that's 95 megabits per second. That's currently being utilized, and if we click on refresh, it'll show whatever's happening at the moment. So if we go back to the cluster by clicking on cluster-2, and with cluster 2 selected, in the tab clicking on VMs, it's showing us here that the primary and secondary are both running. And also, what we should take a look at too is the memory reservation, because each of these VMs is configured for 1 gig of RAM And because we enabled fault tolerance, they both have a 1 gigabyte of RAM reservation that's currently in effect. So to see that, we're here at the cluster. We could just go ahead and click on Monitor regarding the cluster, and then click on Resource Reservation right here. And currently we're looking at the CPU reservation, but for the fault tolerant systems, they are getting a memory reservation. So we'll click on Memory, and right here it's showing us that for VM5, the primary and secondary, they both have reservations, which is going to reduce the amount of remaining memory reservations that are available in this cluster. Great, so let's go back to the VMs tab for cluster 2, and with this row for VM5 primary highlighted, let's go ahead and open up a console. We can do that just by clicking on the shortcut here for Open a Console. I'm also going to take my browser out of full screen so I can see that tab. So here we are looking at VM5, and if we click on the icon for the mouse in the top left of the desktop for VM5, let's go and open up a word processor. Here we have the LibreOffice Writer. So we'll click on that word processor, and let's write a short letter. And in our sample document, we'll do, Dear Mom and Dad, thank you for all you've done for me over the years. I appreciate you both. Everything that's going on here on this primary VM is being replicated in real time over to the standby VM. So let me go ahead and move this around just a little bit. And besides the applications that are running on this virtual machine, if we have TCP-based network sessions, those are also replicated between the primary and the secondary VMs. If we clicked on the mouse again on the desktop of VM5, and then from the menu selected Terminal Emulator, and let me bring that a little bit over here to the left. If we have a TCP-based session, that should replicate. So the question is, what can we use for a great TCP session? I know, how about this? We've got a beautiful VM up here. It's our vCenter Server appliance, and it's at the address 192.168.1.111. I've also enabled SSH access to that virtual machine. So from VM5, which is right here, and we're connected down to the VM network, and then there's a router connected to that VM network. This providing us access to points beyond. It also provides access to the management network, where that vCenter Server appliance is. If we were, for example, to create an SSH session over to the vCenter Server appliance, and then we had an issue where this ESXi host completely went away, that SSH session should still be available on what was the secondary machine, which is now going to be the new primary. And we can demonstrate that here in the lab. So let's do that. So here from a terminal window on VM5, let's type in SSH space -L for login name. We'll log in as root space, and the IP address of our vCenter Server appliance is 192.168.1.111. We'll press enter. It's asking us if we want to continue. Because it doesn't recognize that host as being trusted, we'll type in yes, press enter, and then we'll put in the password of our lab password, which is capital P A $$ lowercase w 0 RD, and press enter. And sure enough, and we can type shell to get a shell, and there we go. If we type in pwd, it shows us the current folder we're in. We can do cd space period to go up a folder. We can do an ls to list the actual file system. Fantastic. It's all working great. So if this ESXi host fails, all this information is being replicated over to the secondary, and it could take control and be the new primary. So I have an alarm here on VM5. Let's take a look and see what it is. So if we click on the alarm here, this is an alarm regarding memory usage on that VM. So I'm going to go ahead and reset that to green. So on the cluster with VM selected, the primary is currently on ESXi2. Now to simulate a failure or to test the fault tolerance, they've given us a really easy way to do that. What we can do is we can right click on VM-5, and from the menu we'll hover over fault tolerance, and check this out. What we can do is we can just click on test failover. And what that's going to do, it's going to make the standby the primary, and that's a great way to test it. So let's click on test failover. I'm also going to close my existing console to VM5. It's still running, so check this out. With a refresh, it's now showing that VM5 primary is powered on. So it looks like it didn't change here, but check this out. It's actually now running as the primary on ESXi3, and the secondary is going to be on ESXi2. Now the secondary isn't quite ready yet, so we have some alarms. One's going to be the high availability, and the other is going to be the state change. And in a few moments, the secondary is also now running. But check this out. If we open up a console to the primary, which is now running on ESXi3, and we can do that by highlighting VM5 here and opening the console. Check this out. Our letter to mom and dad are still good. This session here that we currently have to the vCenter Server appliance is still active. If we press enter a few times, it still works. Hit the up arrow key, run the ls command again. It maintained all of that because it was logging all of those changes from the primary to the secondary, And when there was a fault, or a simulated fault, it switched over and made the secondary the new primary, and it continued on, not missing a beat. So some of the things that would trigger a fault tolerance change and making the secondary now the primary would be things like the host that the primary was running on is no longer available, or there's a network isolation event, where the host that was running the primary identifies that it's got network connectivity issues. That could also trigger the state change to move the primary role to a host that has full connectivity. So my friend, it's now your opportunity to practice what we've done in this nugget in the hands-on labs that we've provided. So have some fun doing it, and I'll see you in the next nugget. Meanwhile, I hope this has been informative for you, and I'd like to thank you for viewing.